Alright, so we are continuing with the August 2020 Mathematics Higher Level Paper 1 Khomas Region exam. And today we are on question 11. Okay, so what we get given here is Onesimus runs from A to B at a constant speed of 4 meters per second. So A to B, so that is 4 meters per second. And then from B to C, he runs at a constant speed of 3 meters per second. He runs at a constant speed from C to A. Okay, so from C to A, it's a constant speed that we don't know yet. His average speed for the whole journey is 3.6. Okay, calculate his speed when he runs from C to A. Okay, so there's a little bit to take into account here. So we know for the whole journey it's 3.6 average speed. We know speed, or average speed, is total distance divided by total time. So in our case, we've got 3.6, that's the average speed, equals the total distance. So 120 plus 180 is 300, plus 150 is 450, so 450, and now we need the total time. Okay, so we can find out what this time is from here to here because we know the distance and the speed, and the same for the second part. So here we can say time equals, so if speed equals distance over time, and then time times speed equals distance, and then time equals distance divided by speed. So time in this case is distance divided by the speed, which is 4. So that gives us a time of 30 seconds. And we can do the same here. So this time would be a distance divided by speed, and that gives us 60 seconds. Okay, good. So we know it's 30 plus 60, so that gives us 90 seconds for that part, for these two sections. Plus, we don't know this time yet, but we know this time is we can just call it t, right? So that's the total time, 90 seconds for this plus whatever the time is for that. And then we can find the time. Like I said, there are always many ways to calculate this. This is just the first one I thought of. There might be quicker ways, but let's see how this goes. So now we need to find the time. Okay, so we can multiply both sides by the denominator. So we get 3.6 multiplied by 90 plus t, the number of seconds, equals 450. And then let's divide both sides by 3.6. So we get 90 plus t equals 450. And, 450 divided by 3.6. So let's quickly check what that is. So we've got 450 divided by 3.6, and that gives us 125. So 125. And then to get t by itself, we just subtract the 90. So we get t equals 35 seconds. Okay, so it took some 35 seconds to run that part. So then what we do is we can find out what is the speed for that part. So the speed from B to C, from C to A, sorry. C to A, we've got speed equals distance over time. So we want to find that speed. We know the distance from C to A is 150. That'll be 150. And we know the time is 35, which we just calculated. So that'll give us the speed of 150 divided by 35. So, ooh, not a nice number. Let's just copy that and paste it. So that is the speed. And then we can round that off to, so that's not an exact number, so then we round it off to 3 significant figures. So to this spot, so the 5 will change that into a 9. That'll be 4.29 meters per second. And again, if you found any other way to do this, you're welcome to share that in the comments below, and we can check that out. I'm sure there are quicker ways to do this one as well. Alright, find angle BAC. So angle BAC, so this guy right here. Okay, so how will we find that? Well, we've got all 3 sides, so we can use our cosine rule here. So the cosine rule says the following. It says a squared is equal to b squared plus c squared minus 2bc times the cosine of a. So we see the important thing is these two things are opposite. So the length squared and the cos of the angle, those are opposite. So in our case, we have this angle that we want to find, so then this is the side that's by itself. Okay, so let's just plug in our values. So our side that's opposite to angle A, the angle that we want to find is 180. So 180 squared equals the other two sides squared added together, minus 2 times each of the other two sides, 150 and 120, and multiply that by the cos of the angle. So what we want to do is we want to get the cos A by itself. So we can start by just subtracting the 150 squared, and then subtracting the 120 squared, and then what's left is this whole thing. So we want to divide by this part next. So we're going to say divided by negative 2 times 150 times 120, and that'll be equal to the cosine of A. And then finally, to get A by itself, instead of cosine of A, we can just say, well, we want to take the arc cos, or the shift cos as we sometimes call it. So we just want to take shift cos of this whole thing, and that'll be equal to our angle. So let's type that one into our calculator. I'm not sure if I can do the inverse of the sine, arc cos here. Let's go to the internet. Okay, so here, did I type this incorrectly? So arc cos, let me just minimize this slightly, and then we can see what we have to type here. Okay, so we've got 180 squared minus 150 squared minus 120 squared, that's right. Divide that whole thing by negative 2 times 150 times 120, negative 2 times 150 times 120, and what we get, that is right, this is in radians, and then we get our angle, 82.8 if we round off to 1 decimal place. Great. Okay, let's just get back to the right page. So here we have 82.8 degrees as our angle. 82.8 to 1 decimal place. Great. So that was just testing if we know the cosine rule. Then question C, the point D is a point on AC that's nearest to B. Okay, so a point on this line that's the closest to this value. So whenever that's the case, we know that's when this one is perpendicular to that side. This will be the point D, right? Because it makes a 90 degree here, so that means this is the closest, the shortest line we can draw from B to AC will be a straight line that makes a 90 degree angle. Okay, so that's pretty good. Now we already know that is 82.8 degrees. So now we can just use basic trigonometry because we have a right angle triangle. So we can say we're looking for this side, so let's just call it X. Actually, let's call it BD, just because we already know it's B and D. So we can say opposite and hypotenuse, that'll be sine that we have to use, right? So I'm just going to write that over here so long, so we can keep the picture in mind. So we're going to say sine of 82.8 is equal to the opposite side, which is BD, divided by the hypotenuse, which is 120. Okay, then multiply both sides by 120, so we get 120 times the sine of, times the sine of 82.8 is equal to the length BD. And that we can just type on our calculator, I'm sure. So 120 times sine of 82.8, that gives us 119.05. So if we do 3 significant figures, since this is not an exact answer, we just do 119. So equals 119. Okay, and let's see, is that the right answer, what we want? The distance from D to A. Ooh. Okay, so we've got DB. So we've calculated DB, or BD, to be 119. Then we need to find what is from A to D. So we've got CA. We know that is equal to 150, right? So that's 150. 150. Okay, actually the important part is, let me just redo this. So we can directly calculate AD from this triangle. Or we could have used this to get Pythagoras now, but then we would have had a rounded off answer in between. So actually what we want to do, instead of taking a longer way, is we can just say we want this distance. So that is the adjacent side. That'll be cos. So cos of 82.8 is equal to the adjacent over the hypotenuse. Multiply both sides by 120. So we get 120 times the cosine of 82.8 equals the length AD, which is what we want. All right. So 120 times the cosine of 82.8, and that gives us 15. Right, 15.0 if we round off to three significant figures. So 15.0. That's AD. And that's all we want. So 15.0 meters. We can ignore this part. That wasn't needed to calculate. Okay, so that's it for question 10, and then we'll be back with question 11 shortly.